to divide complex numbers. Dividing complex numbers. Here's the process for dividing complex numbers. Step 1, you want to eliminate the I in the denominator by using its conjugate and the rationalization process. It's actually pretty much very similar to what you did with rationalizing radical expressions. Recall that you couldn't leave a radical in the denominator, otherwise it's not considered simplified. So in order to remove that radical, you had to rationalize. Well, that's the same thing that you're going to have to do with complex numbers. If you want to remove the imaginary part, the I, you have to rationalize by its conjugate. So the conjugate of 3i, 3i is positive, so the conjugate of that, the opposite of that, would be negative 3i. So now I need to multiply both the top and the bottom by negative 3i so that I can remove the I. So on top, if you multiply that, you have 7 times negative 3i, which is negative 21i. On the bottom, you have 3i times negative 3i, and that's going to equal negative 9i squared. Recall, every time you see I squared, you're going to replace it with negative 1. Negative 9 times negative 1 on the bottom is going to give me a positive 9. Now we're going to go ahead and divide negative 21 divided by 9. We can go ahead and cancel out the common factor of a 3 from the numerical part of those numbers. And that's going to leave us with a final answer of negative 7i over 3. Dividing complex numbers. Notice in this example, the bottom has 2 terms. Still, the problem is that you have an I in the denominator, and we need to remove that I. And the way you remove it is to rationalize by its conjugate. So the conjugate of 5 plus I would be 5 minus I. So we're going to go ahead and multiply the top and the bottom by its conjugate. So on top we have 4 times 5 minus I. On the bottom we can do the F and the L. For the F first term it would be 5 times 5, which is 25. On the last term it would be positive I times negative I, which is negative I squared. Now on the top, notice we also use distributive property. 4 times 5 is 20, and then 4 times negative I is negative I. So you want to go ahead and do both the top and the bottom process. The top was distributive property, the bottom was using the F and L FOIL because you have conjugates. Now we want to go ahead and further simplify that, and every time you see I squared, remember you're going to replace it with negative 1, but with a negative in front of it becomes plus 1. 25 plus 1 gives you 26. At this point we have 2 terms on top that share the same denominator of 26. We can place that 26 underneath each of the terms, so that we can go ahead and simplify these fractions. And once we simplify by taking out the common factor, what we are left with is 10 over 13 minus 2i. Now, of course, you can also write that answer with the denominator being just 1, placing the common denominator, in other words, under both terms. So then it would be 10 minus 2i over 13. In this last example, we're going to divide these complex numbers. So we again have an I in the denominator. So in order to remove that, we're going to have to rationalize by its conjugate. The conjugate of 4 minus 3i is 4 plus 3i. So let's go ahead and multiply the top and the bottom by that. So what we have is two binomials on top, so the only way you're going to simplify that is to FOIL first, outer, inner, last. On the bottom, because you have conjugates, you only need to do the F and the L, first and last. So when we do so, it's going to look like so. Remember, everywhere where you see I squared, you're going to replace it with -1. Continue to do the math. Of combining like terms, combine like terms on the top and on the bottom. So on the top, we can combine 24 and -6 because those are your integers. And then on the bottom, combining 16 with 9. And that's going to leave us with an answer of 18 plus 26i over 25. Now here we wrote both terms over its common denominator. You can also write it that 25 underneath each term, meaning you can write the 25 underneath the real number and write it underneath the imaginary number. That form of answer is also correct as well. So in your homework, you can enter your answer as either form, and it is perfectly acceptable. And that's dividing complex numbers. There you have it.